By way of review, then, let's ask the question, what is anthropology? And as pointed out, anthropology is interested in really humankind from a variety of different perspectives. We had talked about cultural anthropology, we had talked about archaeological anthropology, linguistic, and physical anthropology. And the point of emphasis in each one of these inquiries or fields within anthropology is understanding humankind. Let's move to the next slide. So, anthropology, it comes from two basic words, logos in Greek, which means the study of, plus anthropos, which means mankind. Now, we want to correct that. This is the original definition, translation, but we're not interested in more than just men. We're interested in humans in general. Let's move on to the next slide. Anthropology goes pretty far back into the past. So how can we know the past? Here I just want to focus on a couple of tools that'll help us understand where some of this information that we're going to be talking about throughout the course comes from. Written records, they do provide us with information. For example, Boccaccio in the Decameron, he documented, he lived through the Black Death in the 1300s, and he documented what was taking place. Now, those are great records that we can use, again, to interpret the impact that that particular disease had upon people in, for example, Italy. Beyond that, we want to go a little bit further. So paleoanthropology, we had said that this is a subfield within physical anthropology, and they're interested in fossils and analyzing fossils and trying to figure out a little bit about the past. As we progress to other fields, for example, archaeology, they're interested in artifacts, whether they're material or they're biological artifacts, so the objects that people have left behind, in addition to human remains. All of that stuff can be analyzed. Written records, they provide us with a great information. Written records start approximately 6000 BCE, or about 8,000 years before the present. We can also use something that's called radiometric or absolute dating. This tells us when things happened. For example, when a person died, and we can use that information to, again, build an understanding of the past. In more recent times, we've been able to use molecular biology and anthropology, for example, to extract DNA from teeth and gain insight into the diseases that impacted that individual. We even look at the dental calculus on an individual's teeth and analyze the types of bacteria that are in there, and that tells us a whole lot about their health as well. Let's move on to the next slide. In addition to anthropology, we're also going to draw upon history. So very briefly, let's look at the origins, at least the ancient origins of history and the focus. History as a discipline, it's often traced to an ancient Greek by the name of Herodotus, and he was interested in recording and understanding differing beliefs and histories of people, the types of events that they experienced. Sometimes he's regarded as one of the fathers of cultural anthropology as well. As for a definition of history, we want to say that historians are interested in the discovery, the study, and the organization of past events during the historical period. That's kind of a key point. So we have two periods. We have prehistory and we have history. When does the historical period begin? The historical period begins at different points of time depending upon when writing was invented. With the ancient Sumerians, for example, they invented writing at around 6,000 years before the present. Ancient Egypt invents writing at around 5,500 years before the present. So we have different historical periods emerging roughly around the same time, and this is what historians are interested in. How do they collect information? They'll draw upon archaeology, all of the artifacts and interpretations that archaeologists have, for example, discovering ancient hieroglyphics. They'll interpret that information as well. So documents is really a key feature here when we're looking at history. Let's move on to the next slide. Moving beyond the historical period, we have an immense period of time that's referred to as prehistory or the prehistorical period. The prehistorical period, we define it as everything that has happened prior to the invention of writing. It goes back hundreds, thousands of millions of years ago. So we have two basic areas that we've looked at. We have prehistory and we have history. But we're going to find that there's a number of ways that people refer to time. Let's look at a chart on the right. So here we have prehistory, the historical period, BC, AD, BCE, CE, MYA, and YBP. Well, because. Usually that joke works in class. Okay, prehistory. This means everything prior to the invention of writing. And it's used quite often by physical anthropologists and archaeologists, also paleontologists, people who study, for example, dinosaurs. The historical period, this refers to everything following the invention of writing, and it's often used by archaeologists and historians. BC and AD, we often see this in writing, and in anthropology, we try to avoid it. BC means before Christ. AD does not mean after death. It means in the year of our Lord, or Anno Domini. Now that religious bias is a problem. It's not that anthropology doesn't like religion. It's that not all people are Christian. So it's not appropriate to impose a religiously biased system on, for example, Muslims, Hindus, or people who are Judaic. So we try to avoid that terminology. In contrast, we can use BCE or CE. Now it refers to the same time frame. It just means before the Common Era or the Common Era. MYA refers to millions of years ago. And it's used by quite often paleontologists or paleoanthropologists. YBP, this refers to years before the present. YBP. And it's based upon a dating system that we're going to talk about in a second, carbon-14 dating. So a good question for the test would be, what do some of these mean? For example, what does MYA mean? What does a physical anthropologist prefer to use? Would they use BC? Would they use AD? What would an archaeologist prefer to use? Or what area would they prefer to study? Let's move to the next slide. Let's look at a couple of subfields and how they get at dating time or interpreting some of this information. Paleoanthropology, it's derived from three words, paleo, anthropos, and logos. It means the study of old humankind. That's what paleo means, old. So this science, it studies the evolution of humans or hominids through the fossil record. Now this is good and fine if we're looking at fossils, but one of the main questions becomes, well, how do we begin to align our fossils? How do we know that this fossil is older than that fossil? Now it wasn't until the work of Marie Curie and her identification of radioactive elements that we were able to begin to date the sediment that fossils are found in. So with respect to paleoanthropology, we kind of step into a time machine. We date the sediment that fossils are found in, volcanic material. That stuff can be radiometric dated and give us a precise date for when that individual's remains were deposited in that layer in the ground. A fossil. What's a fossil? Fossils are fascinating. We have a variety of different fossils, and ultimately, it's an impression of the past. It's no longer organic. It's an inorganic impression of the past. And this is one of the reasons why we can't use, for example, carbon-14 on a fossil. Carbon-14 works with organic materials. Let's move on to the next slide. We have a couple of methods then that we'll use to determine chronological age, or how old a fossil or a bone is. Let's move to the next slide. Radiometric dating is also called absolute dating because it gives us a precise date rather than a guesstimate. So in paleoanthropology, one of the methods that's used is something called KAR40 dating, or potassium argon 40. We're able to date the sediment that a fossil is found in, providing it is volcanic material. Volcanic material is radioactive. And the process goes like this. So while lava is molten, it contains argon 40, it contains potassium 40. However, when that lava hardens, there's no more argon 40 within it. The interesting thing about potassium 40 is it's not a stable isotope. It decays over time. Decaying. Think of, for example, water evaporating. Water is not stable. It will evaporate or decay over time. So over time then, potassium 40 is decaying into argon 40. And because we understand this process, we can measure the ratio of change over time. And what we know is it takes 1.3 billion years to get half of the amount of potassium 40 that you started off with. So if you find an equal amount of potassium 40 to argon 40, we would know that 1.3 billion years has passed. Let's move on to the next slide and take a look at carbon 14 dating, because that works with time frames that we can understand a little easier. Let's move ahead. Archaeology, they tend to use carbon 14 dating or C14 dating. Now, C14, it's also an unstable isotope. So here we see an image of a bone, hard tissue, and we have a number of different carbon isotopes. In our own bones, we have a lot of carbon 12, and that's stable. It doesn't change over time. We also have some carbon 13, that's stable. It doesn't change over time. In contrast, carbon 14, and we have just a tiny amount of carbon 14, it's not stable and it decays over time. So like I said, we measure a ratio of change, and that tells us how old something is. Now, I had said that when we look at K40 or potassium 40, the half-life is 1.3 billion years. The half-life of carbon 14 is not that old. So this doesn't allow us to go that far back in time. The half-life of carbon 14 is 5,730 years. So every time we see a change take place, we see half of the amount of carbon 14 that we started out with. We know that 5,730 years have passed. Now, it'll take another 5,730 years to reach half of that amount of carbon 14. So it's kind of like this. Let's look at this process of decay. When we die, it's kind of like nature shakes us up a little bit, and that carbon 14, it begins to disappear, leaving us with a ratio that can be measured precisely over time. Now, carbon 14 dating, it's going to take us back about 50 to 60,000 years, and we can only use it on organic matter. So here we can use it on bone. We see a good image of that. We can also use it on linens. Well, that's an organic material, so it allows us to date clothing. In addition to linen, we can use it on wood, charred woods, and it'll tell us how old that wood was or when it was cut down. Let's move on to the next slide. Paleopathology is a specialization within anthropology that examines old disease. It's regularly used within physical anthropology and archaeology as well, in a subfield that we refer to as bioarchaeology. We could say paleopathology then is the study of diseases prehistoric and historical peoples experienced. And we can get at this information in a few different ways. On the left-hand side of the screen, for example, we're looking at the bacterium that's responsible for causing syphilis. Now, syphilis has been an area of interest for anthropologists or individuals tracking disease, specifically from a point we want to understand when this emerged and began to afflict populations in Europe. So we're looking at a Treponemia pallidum, as pointed out. This is a bacterium. And we've been able to get at this information in a few different ways. So paleopathology, for example, a couple of sources it might use. We can look at bones or hard tissue. We can look at mummies to examine some of these soft tissue sources for disease. And we can also look at the availability of bacterium in teeth and dental pulp, and that can be extracted and examined. Let's move on to the next slide. Here we have an example of a skull. We see the cranial vault with a number of unique features on it. What we're looking at is something that we refer to as an osteoblastic lesion, so bone-creating lesions, in addition to osteolytic or bone-eating lesions. Now, disease is interesting because it will afflict or attack certain areas of the body. Tuberculosis, for example, loves to go for the hips and the spine in addition to the lungs. Smallpox, for example, it impacted skin, causing very characteristic pustules or eruptions. Now, when we're looking at hard tissue, we can't see the way that disease would have impacted the soft tissue. Fortunately, for the study of paleopathology, disease does tend to have a signature. It leaves very specific marks in specific areas of the bone. And here we can look at this skull. This is not caused by tuberculosis. This is not caused by leprosy. The only thing that would cause this type of characteristic feature on bone would in fact be syphilis. Let's take a look at a few examples of the way that disease affects bone or the signatures that it leaves behind. Let's move on to the next slide. If you're following along in your text, you're going to see a specific feature called "It's in the Bones." And that feature in our text, that specific box, deals with an examination of disease from a paleopathology perspective, often a bioarchaeological perspective. And we're trying to get that evidence that we need to confirm when disease began to affect certain populations. Let's move on to the next slide and look at a few examples. Here we're looking at a condition called enamel hypoplasia. And the thing about bone is it has a type of continual growth pattern. We're very different from trees in a number of ways, as you can imagine. But if we cut a tree in half, we could see its arrest lines, where that tree has gone through periods of development and then it goes into dormancy. Now that's normal for a tree. Humans, however, we don't go into periods of dormancy unless we're impacted, for example, by famine, and that will be shown in the bones. So these lines that I've indicated with that black arrow, we can see those linear lines. It's called linear enamel hypoplasia, sometimes just LEH. And that tells us that this individual, as they were developing, their growth was disrupted. Now that could be, for example, the cause of malnutrition. It could also be the cause of a metabolic disease that impacted their ability to take in nutrients and process them properly. But either way, it's this type of information that gives us some insight into the health conditions of past peoples. Let's move on to the next slide and take a look at another example. This long bone demonstrates something very similar to enamel hypoplasia. What we're looking at are arrest lines. We shouldn't see this if a person's growth patterns weren't disrupted. I wouldn't be surprised if you saw a picture on your test that asked you to identify the feature that we're looking at and the cause. So we want to be able to say Harris lines inform us about growth patterns. This is in the type of arrest line or where growth has stopped due to nutritional issues. Let's look at another example. Cribra orbitelia is another remarkable condition that's also caused by a deficiency. So this coral-like feature that we're seeing inside the sockets of this cranium, that's not normal. This is caused by iron deficiency. So in this condition, we would point out that the individual suffered from anemia, and anemia can be caused by a few different things. For example, individuals that have diets that are very high in phytic acid. So a person who eats a lot of unleavened bread might have this condition. And in fact, archaeologically speaking, we see at a certain point in time in history when humans start to rely on grains and they're not leavening those grains, we see an abundance of cribra orbitelia. The other thing that can cause anemic conditions is malaria. So this could also provide insight into malaria. We'd need to engage in a little bit more analysis. For example, we'd want to take a look at the individual's teeth, extract some of that dental pulp, analyze it, and see whether or not we could identify the Plasmodium falciparum, that's responsible for causing malaria. Let's move on to the next slide. We'll also talk about leprosy in the archaeological record. It's been another area where anthropologists, archaeologists have wanted to identify at what point of time did leprosy begin to affect populations throughout the Middle East and into Europe. The condition here that we're looking at is very characteristic of leprosy. If you look at, for example, the metacarpals, you can see that they're very spindly as we get to the distal ends of those bones. In addition to affecting the feet, leprosy also affects one's hands and pretty much causes the same type of condition, and it'll also affect the cranium as well. Let's move to the next slide. What then can be learned by studying the history of disease in medicine, and why, for example, according to me, is it so fascinating? I think this is a really important area that can provide us with a lot of information, not only about the past, but begin to prepare us for the future and help us understand how human action, human behavior, culture is just as much to blame for disease as the biological organisms that are responsible for causing disease, for example, bacteria and viruses. Let's move to the next slide. I want to borrow a couple of ideas from William McNeill, who wrote a book called Plagues and Peoples in about 1976. It was immensely important because one of the things that it underscored was that by looking at plagues and peoples, it helps us understand the relationship that exists between humans and other forms of life. We do not live in a vacuum. We have an immense impact upon the world around us, as we're learning right now. So balance, this, or homeostasis, this is a principle of evolution. Things tend to balance out over time. So if balance is a basic feature of an ecosystem, what happens when humans disrupt that ecosystem? Well, things can drastically go wrong for the species that live in that ecosystem, but we often think, or fail to think, that it can have an impact on us as well. Let's take a look at an example. Lyme disease. Lyme disease wasn't a big problem early 2000s in the Greater Toronto area. 2006, still not an issue. More recently, Lyme disease has become a problem. Why? What's going on? Let's move to the next slide. Lyme disease is caused by Borrelia burgdorferi, and there's a few species here in this chain of transmission. So Borrelia burgdorferi, it normally resides in white-footed deer mice. They're the reservoir. It's transmitted or vectored from mice to humans and other species through ticks. As pointed out, this wasn't a big problem in the GTA until humans began to encroach or move into some of these areas. You know, it's great to live in an area where you back on, say, to a field, but in backing onto that field, we're moving into an area where there was an established balance, and now we're inserting ourselves into an area that might have an abundance of white-footed deer mice, in addition, deer and ticks. And that's a perfect recipe for seeing this increase in the distribution or the morbidity of Lyme disease in recent times. Let's move to the next slide and look at another example. As pointed out in our textbook, Lyme disease is caused by Borrelia burgdorferi. This is a bacterium. It normally resides or lives in white-footed deer mice. It doesn't make them sick. We refer to the deer mouse in this situation as the natural reservoir. Now, the bacteria makes its way out of this reservoir through a vector or an insect that's responsible for transmitting it between species. ticks, for example. So ticks, in the case of Lyme disease, are responsible for vectoring Borrelia burgdorferi to other animals, including deer, and eventually humans. Now, what role did humans play in this ecological system, allowing for an increase in the distribution or the morbidity of Lyme disease, such that it's becoming a problem today? Well, with the development of new homes, specifically in areas where we tend to have more forested areas or meadows, these are some of the highly desirable areas that they're charging a lot of money for in recent times. We begin to encroach into these environments. And encroaching into those environments or inserting ourselves into that environment, we're creating a situation that we're more susceptible to disease because we've disrupted the natural balance. We've placed ourselves in this cycle of disease, and we end up being one of the dead end hosts for Lyme disease. Let's move to the next slide. As pointed out in our textbook, the Nipah Valley fever, this emerges in the 1990s. It's caused by a virus referred to as NIV, and this is all about farming. As populations began to increase in Malaysia, a number of local farmers started to increase their farming businesses, and there was a situation where bats were brought into close proximity to pigs. Bats carry a lot of diseases, and they carry NIV. The bats, they would be responsible for infecting some of the fruit on the trees where people were growing fruit as part of their farms, and also the ground in their feces. The fruit would fall to the ground. Pigs would consume that fruit with the saliva of the bat on it, and they would get infected. Similarly, humans, if they didn't wash the fruit well enough, they would get infected with the virus. Or if humans came into contact with a pig, its saliva, and that pig was infected, the human would get sick. Or if the meat wasn't properly cooked, that would also cause infection. Again, this was about the emergence of farming and how it was done really in a improper manner. Let's move to the next slide. During the 1990s, Malaysia saw the emergence of Nipah Valley fever, and only recently have they achieved vaccine for this virus, NIV. The 1990s then saw population growth in Malaysia and the expansion of local farms, generally speaking small farms, that eventually grew into larger farms that not only grew fruit but also raised pigs. And this led to a spillover event. Now, what ended up happening was the portions of the farm that grew fruit, bats came to that area, they ate the fruit, and they infected the fruit with their saliva and also the ground with their feces. This is also the same area or the ecological system that had been created, manufactured, an artificial ecological system that brought pigs into close contact, not only with the infected fruit, but the bats as well. In the end, humans and pigs, they consumed infected fruit. Humans consumed pig, or they came into contact with bat saliva in a variety of different ways, or pig saliva, and this led to the emergence, as pointed out, of the Nipah Valley fever. And only recently have we been able to address this. Let's move to the next slide. Coronavirus, COVID-19, is caused by a virus, a SARS virus. It's referred to as SARS-CoV-2. Science has been able to trace this back so far to bat reservoirs. And in 2007, a bat sample referred to as RATG13 was found to contain, when analyzed in recent times, was found to contain almost a genetically identical coronavirus to the one that's causing our sickness today. So we don't know if our illness, the human COVID, was a direct spillover event from bat populations, or if there was an intermediate species involved, an anteater, or what's referred to as a pangolin. This quite possibly can be an intermediate species. We haven't been able to figure out the genetics as of yet and identify a particular source. But the thinking is that this highly sought after meat, pangolins, their black market in China, it was brought into a wet market. Quite possibly it infected other animals as well as humans, and this is what caused the emergence of the COVID-19 pandemic. Again, the science, we're still working on this. Scientists are trying to figure out the origins, but this is where the best science is today. Let's move on to the next slide. In December 2019, a new illness emerged in China, and by January 2020, not only had the illness been defined as COVID-19, but the virus responsible for the disease, SARS-CoV-2, had been identified. Coronaviruses, they have been observed for some time. We're constantly watching bat populations and coronaviruses, specifically in Asia, because from time to time there are some nasty infections. For example, in our textbook, it points out in the 1800s, one of the viruses responsible for the common cold today was responsible for killing millions of people. With respect to the common cold, a number of coronavirus strains are responsible for those infections that we get today. Either way, in about 2017, a new cave system had been discovered in the Yunnan province. It's referred to as the Yunnan cave. And there, researchers had collected some samples, in specific RATG13. Now, apparently this was stored in the Wuhan lab for a period of time, and with the emergence of SARS-CoV-2, researchers took a look at some of the viral strains that they had collected, and RATG13 was defined as the closest genetic ancestor to the current virus that's circulating today. So these Yunnan bats, and RATG13 is suspected to be the reservoir that was responsible for this spillover event. Now, we're not sure whether or not this was a direct spillover event from bats to humans. Science hasn't been able to provide us with any more information on that, or if an intermediate species was involved. For example, these anteaters, pangolins, which fit into the black market in China, their meat and their scales are highly desirable. So they're possibly an intermediate species. I have a question mark there because a lot of the evidence is still inconclusive. We've looked at the viruses that as they exist in the pangolins, and they're not genetically close enough. So it was possibly contracted by a pangolin who was brought illegally into the market, perhaps transmitted to other species within that wet market, and eventually humans. That's one of the models out there. If it is, again, this provides us with another example how humans augment environments and really create unnatural or artificial settings that are conducive to the emergence of disease. Let's move to the next slide. As pointed out in our introductory lectures, anthropology doesn't engage in that nature versus nurture debate. In contrast, we engage in a biocultural approach, and in doing so, we look at the interplay between biology and culture. Now, in medical anthropology, we're going to use the same type of approach, and we're going to say that disease is just as much a cultural phenomenon as it is a biological one. In other words, COVID-19, there's no question that this is caused by a virus, SARS-CoV-2, the human variant. If we didn't pursue into the role of human behavior and we left it just at biology, we would be remiss. We would be negligent, and we would fail to understand how human behavior and culture has created an epidemiological landscape that has really caused the world to close down. So what are the possibilities? I'm going to go through some of the research here. So some researchers are looking at the role that stressed bat populations may be playing in the emergence of this disease. And this is ultimately traced to the role of climate change or perhaps encroachment, and it's led to a direct spillover event. So what I want you to imagine is some people, they get cold sores, and they tend to get cold sores when they're stressed. This is the same type of thinking with bat populations. So because of human-induced climate change and us encroaching into their areas, cutting their forests, we've stressed that population, and that perhaps led to a direct spillover event. In addition to that, there's also the idea that perhaps wet markets and the creation of an unnatural environment has led to spillover event with a potential intermediate species, or perhaps others that have led to a recombination event and has infected some individuals. That's entirely possible. In addition to that, there's also the possibility of undetected spillover events. For example, local hunting or collection, exploration of the cave systems, that's something that's going on as well. And it's very possible that this spillover event went undetected. I want to take you back to about 2010 to give you an example. In China, there was an outbreak of bubonic plague. And that was traced to trappers who had been hunting and collecting game, and in doing so, they infected themselves with the bubonic plague, Yersinia pestis. There's also the possibility that this is an escaped virus. People have been exploring this theory. We need to take out the idea that there was any purposeful intent to create a dangerous virus. That is something that people have been using to stigmatize and create political issues between China and nations around the world. We don't want to do that. But we do have examples that viruses have escaped from time to time from labs, and this may have in fact led to a spillover event. We don't know. Only time will tell. Like I said, here are a number of theories that people are working on, and with more scientific evidence, we'll be able to say exactly what happened, and hopefully we'll be able to act on that knowledge and prevent a future outbreak of disease. Let's move to the next slide. So, by examining the history of disease and how people have responded, we also gain insight into understanding how people have attempted to predict, order, and explain phenomena over time. And in doing so, we gain a glimpse into the culture of past peoples and the illnesses that they've experienced and how they have interpreted it. So, for example, on the right-hand side of the screen, we're looking at something called trephination. Now, this procedure, individuals would drill holes into other people's heads with rocks. So this is stone tool technology. And this particular individual, they succumbed to the procedure. We can see 3 holes there that really show no sign of bone remodeling. There is a healed 4th hole, and we can see that on the frontal bone just next to those 3 holes, type of a little divot feature. The question is, why does somebody drill a hole into someone else's head? Now, the conventional thinking is maybe they were doing the same thing we do. We engage in this type of trephining process when we need to reduce intracranial pressure, for example, after severe head trauma. So we could look at the skull and see whether or not there's any evidence of a fracture and if that's what was happening. And in some situations, we do see 1 hole, we see a fracture, and perhaps they understood the problem of concussion and that swelling brain and this released pressure. One possibility. The other type of traditional explanation would be they were releasing evil demons, spirits inside of somebody's head. Now, we have 2 options. We can either approach that for what it is and say, okay, some people believe that demons possess them, or we could say, what would the scientific perspective be? And if somebody's acting erratically, perhaps we're looking at an instance of schizophrenia. Perhaps we're looking at multiple personality disorder or some other psychopathology. And when we see these holes, a number of holes, what we're looking at is a form of ancient neurosurgery in an attempt to address mental health. Now, interestingly, this stuff goes back about 13,000 years before the present, if not older. Let's move on to the next slide. Finally, by looking at epidemic disease and how people have responded to it over time, we develop an appreciation for not only how humans have responded to tragedy, but how tragedy has shaped our world and our worldview. So, for example, in 2002, I defended my graduate work on epidemics and cultural change, and in it I argued that every time that we see a new medical system or belief system emerge, kind of building upon this Thomas Kuhn's paradigm shift, that there is in fact an epidemic behind it, causing stress and leading to that change. So, for example, when we look at the Black Death, of course, it was a massive biological event. However, it did play a role in shaping human history. It shaped the development of art, it shaped the development of religion, as well as the economy. And in fact, some people argue that the Black Death set the stage for the emergence of the Renaissance. Let's move to the next slide. In 2002, I defended my graduate work that ultimately examined the role that epidemic disease plays in shaping our beliefs. And one of the basic questions that drove my research was, how can we explain the emergence of new explanatory systems in medicine? Now, medicine's not any different than, for example, religion from a belief perspective. For example, if you believe in a god, or say gods, or maybe some sort of a spiritual force, or the lack thereof gods. If somebody came along to you and said, God doesn't exist, or the gods don't exist, and they offered you a new system, are you likely to say, hey, yeah, you're right, let me adopt your belief system? It's highly unlikely. In contrast, if some sort of situation led you to question your fundamental beliefs, in that period of, maybe we can use the word weakness, where you lack faith in your system, you're more likely to adopt a new system that explains things better. So, it's during periods of relative deprivation, when we're deprived, when we go through economic, biological, psychological, cultural, or social strife, that we tend to question our belief system. And if another system emerges in this period and revitalizes our beliefs, it's likely adopted. So ultimately, I argued it was during periods of deprivation and stress that the old explanatory systems, when they failed, they were rejected. They didn't offer the adequate explanation for individuals to help them understand what was going on, help them understand or make sense of the world around them. New systems that explain things better, they revitalized the society's culture. And this is why we see cultural change in medicine quite often throughout the history of humankind, is because of those epidemics that cause situations of relative deprivation. Now think, what types of deprivation are we currently experiencing during COVID-19? And in what way might that impact our belief system today? I'll let you think about that. We'll leave it here. Have a great day. I'll talk to you later. Take care.